Engineers Talk series organized by the Institution of Engineers, Salem Local Center as part of the celebration of its 32nd anniversary. Today's webinar is titled Think Parallel Java Multithreading Unleashed, a topic that explores one of the most powerful concepts in modern software development and computing. I extend a warm welcome to our distinguished dignitaries, esteemed members of IEI, faculty members, students, professionals, and all participants who have joined us this evening. To formally welcome the gathering, I now invite Engineer S. Loganathan Sir, FIE Chairman, IEI Salem Local Center and National Council Member IEI, to deliver the welcome address. Sir, please.
Yeah, thank you, ma'am. Am I audible, ma'am?
Yes, sir, you're audible, sir.
Okay. Actually, due to some urgency, again, sir, unable to join today. So, on behalf of Lonan sir, myself, I'm K. Tangraj. I am the immediate past chairman of ISL Local Center. I am welcoming the gathering. Respected Lonan sir, in absentia, Dr. R. Satish Kumar sir, Honorary Secretary of ISL Salem Local Center, our senior members, and today's chief guest, Dr. K.N. Singh, Assistant Professor 2, School of Computer Applications, Kalinga Institute of Industrial Technology, Bhubaneswar. Thank you, sir, for joining with us today and going to deliver a wonderful again lecture that is again need for the day. Think Parallel, Java Multithreading Unleashed. On behalf of IAS Salem Local Center and our committee members, I thank each and everyone. We are in the 32nd anniversary of our IAS Salem Local Center, and also this is our 139th special webinar. Today again webinar is under the aegis of Computer Division Board. Our continuous again weekly knowledge sharing serious engineers talk. For that also thank our chairman Lonan sir and also Secretary Satish Kumar sir for wonderfully again they are maintaining the decorum and again continuing with again full effort to enrich all the participants of our IEL Salem Local Center. Once again, I welcome you all for the wonderful session. Thank you, sir. Thank you all.
Thank you, sir, for your warm welcome. It is now my privilege to introduce our esteemed chief guest and keynote speaker, Dr. Kamakya Narayan Singh. Currently, he is serving as assistant professor in the School of Computer Applications at Kalinga Institute of Industrial Technology, Bhubaneswar, Odisha. He is a distinguished academician, researcher, and educator with nearly 18 years of combined experience in industry and academia. He holds a PhD in computer science and IT from Maharaja Sriram Chandrabanja Dio University, an MTech in computer science and engineering from Jawaharlal Nehru Technological University, and an MCA from the University of Hyderabad. He began his professional career as a software engineer at Softment Technologies in 2007 and has since made significant contributions to both teaching and research. His areas of expertise include machine learning, clinical decision support systems, Internet of Things, sensor networks, soft computing, programming languages, and data structures. He has authored and co authored numerous research papers, conference publications, and book chapters. He is also the author of a textbook on advanced Java. A dedicated researcher and lifelong learner, Dr. Singh is a UGC NET qualified scholar, a lifetime member of the Indian Society for Technical Education, and a dealing certified trainer. His recent research focuses on machine learning based healthcare solutions and disease prediction models, reflecting his commitment to using technology for societal benefit. Today, we are truly fortunate to have such an accomplished scholar, researcher, and mentor among us. His vast knowledge, rich experience, and valuable insights will undoubtedly inspire and enlighten us all. Thank you, sir, for accepting our invitation. May I now request you, sir, to deliver your keynote address?
Thank you. Thank you. Yeah, thank you, all of you, respected sirs and madam. It's my great honor and privilege to deliver a talk on such a STEAM platform. I think one of the oldest platform in the country. I won't waste much of the time. I directly start the topic. Am I audible?
Yes, sir, you're audible, sir.
Yes, sir.
Okay. So topic is multi-threading in Java. I hope all of you, maybe the some of the you might be familiar about the Java and also thread in Java. So all of you know that Java is a very popular and green ever language. There are so many features of the Java becomes popular, but like platform independent, Bora, etc. But one of the feature is multi-threaded. So let me share the slides. Slides is visible now?
Yes, sir, it is visible.
Okay. Thank you.
Thank you, sir.
Not moving. Okay, so these are the objectives which I am going to cover within 45 minutes. We will try to understand how threads are created and implemented in Java. Also, how many threads, what are the applications, how we can, there is a new, maybe the old concept also, but I would like to give the one case study and real-time example of the daemon thread and non-daemon thread in the Java. So thread is a lightweight, a smallest part of a process. How we can say that a sub-process that can run concurrently with the other parts of the thread in the same process. And the process of executing multiple threads simultaneously is known as multi-threading. Why multi-threading is required? Because all of you know that nowadays everyone want to perform multitasking in a less amount of time. So there are two ways of multitasking can be done. One using process-based and second using thread-based. So here we will focus using the thread-based and some part of the also process-based. So what is the process? All of you know that a program execution is called as a process. And thread is a lightweight sub-process, means part of the process. As I told you, there are two ways that can be used to complete a multitasking. One using process-based and one using thread-based. So why we can't prefer to process-based? Because process required separate chunk of memory. Since process required separate chunk of the memory, so if we use process to complete a multitasking, then it takes much of the time. It becomes the expensive. Why? Because communications between process to process is expensive. While thread is a lightweight sub-process and it shares the same memory address space. Means in a common memory address space, more than one thread can be shared. So if we prefer to complete the multitasking using thread, then it can take less time as compared to process. It is the communications between process to process is inexpensive. So as I already discussed with the difference between process and thread, so I will move these slides. Now multi-threading. Am I audible?
Yes, sir, you are audible, sir.
Actually, network problem is my office in chamber now. This is the off time, na? That's what I'm asking. Network is anyway. So multi-threading enables program to have more than one execution path, and both are the independent paths. Both the threads are the independent parts. So it executes concurrently. So what is the basic advantage? Because both are the independent. So even one thread goes down with the any region, so other thread does not affect. But in case of the process, this is not happening. Each such path of execution is a thread. There are two ways in Java using we can create the thread. One using the thread class and second using the runnable interface. In Java, there is a thread is a predefined class which is available inside the java.lang package. And that is the freely, no need to, implicitly imported. No need to explicitly imported. Implicitly we can do it. So that there is a some predefined method in this class, like run method, start method, and there are so many other methods also, join, waiting, sleep. When after this, I will explain the life cycle of the thread. So run method is available inside the thread class. This is the predefined method. Whatever, as I told you, we will prefer the thread to complete a multitasking. So whatever the parts of a task we want to do, that can be written inside the run method. And in Java, what happens? Any method which we implement that need to be executions inside the main method, we must call that method. But here run method, we are not provoking directly. We will call the start method, and JVM provokes the run method internally. So here directly we are not going to provoke the run method. Look at here. Inside this methods, we can write the whatever task we wanted to complete it. So there are two ways. One using the extends thread class, and second using the implements runnable interface. I will show you some couple of examples also. These are the methods that can belongs inside the run method. Current thread, active counts, get ID, get name, etc. etc. What happens when we create a threads, then there are three constructors of the predefined three constructor of a thread class. Constructor is a nothing but a special method which name should be same as a class name that does not return anything and used to initialize the variable and create the object. So similarly, thread constructors can be used to create a thread, user-defined threads. So what we will do, there are three types of the constructor: without parameter, one parameters, and three parameters. So in three parameters, we can pass the every threads, whatever threads we are going to create, that belongs to, that has their name, that has their priority, and that belongs to any group, thread group. So by default, whatever threads we are going to create, that belongs to the main thread. And priority, there are three types of the priority in the threads. One is the minimum priority, second is the average priority or normal priority, and third one is the maximum priority. They are having the some integer value. Minimum priority value, thread priority value is 1, normal priority thread priority is 5, and maximum priority value is 10. But we can change it. We can set the priority. We can change the priority. Why we can change the? Why we can set the priority? If one thread is executing and if higher priority threads comes, then thread scheduler temporarily pause it and assign to the higher priority threads to complete the task. Once the higher priority thread will complete the task, then it will assign to again the lower priority threads, and it will start from the task where it has left off. So these are the some predefined method also. These are the three constructors which I was talking about. The thread constructor, here we are passing the one arguments, only thread name. Here we are passing the three arguments, thread group also, name also, and maybe priority also. So main thread, by default thread name is the main thread. When the execution of Java program starts, the JVM creates the main threads and calls the program's main method within the threads. So programs can always take control of the main threads, but we can change it. We can give the name of our user-defined threads also. Chennai, Patna, Bhubaneswar, XYZ, whatever we want, we can. They are predefined method. Set name, set priority, get priority means we can set the name. Then we can get the name whether we have set successfully or not. Similarly, we can set the priority also. Similarly, we can change or set the thread groups also. So these are the, and we can change the using current threads whether this thread is existing or not. There are so many inbuilt methods. Here I will show you one example. Look at there. We are checking thread.current thread because this current threads belong to this thread class. This is a predefined class. Then here we are setting the name. By default, name is the main thread, but here we can set the new thread or any name but, which we want to assign. Similarly, we can set the priority also. Similarly, we can set the thread group also. We can communicate also. Look at there in current thread without changing the name. By default, thread name is the main, priority is 5 by default priority, and thread group is the also main. When we have here set the name, look at here we have set the name new thread, and again we are going to check the name whether we have successfully set or not. Then after renaming the threads, look at there, thread name got changed. Earlier it was the main thread, now it becomes the new thread. Priority we didn't set here, we didn't change, so priority is still 5. Similarly, thread group we didn't change in this program, so still thread group is the same like previous main, but this can be also changed. Priority also can be changed, and thread group also can be changed. Here are the two ways: extending thread class and implementing the runnable interface. Here run method belongs to thread class as well as runnable interface both. But when we will implement, then we have to implement the way like other interfaces we are using in implementing in Java. And when we are using the thread class, then we are extending, we have to extend. And both the cases, we have to override the run method. Why? Because I told you whatever the task we have to complete, we will write inside the run method only. And then we have to call the start method to initiate the thread execution. And every thread has the life cycle phases. Complete examples I will show you. I have the programs also. I will just look at here. The logic we have written inside the run method. Here we have created the object thread1, and we are not provoking the run method. We are provoking the start method. And this start method, JVM provoke internally run method through this start method. It will be more clear during the life cycle method. So similar way, we can go for the creating a thread using the runnable interface. Here look at runnable interface is implemented by the thread class interface runnable. And look at here again, run method is available inside the run method and thread class both. Here again, we need not be call the directly run method. We have to provoke the start method only. So these are the some predefined method inside the runnable interface also. Some of the methods are the common. Here, look at in this example, we are using the implements runnable interface. So here we have created two threads. One is the thread child. Here run method. We are going to simply display the 1 to 5. Just we are giving the demo. And as I told you, there are the various methods available inside this thread class. One of the method is the sleep method. And this value passing in the milliseconds means for 500 milliseconds, thread is going to sleep. it means other trades is not going to become ideal. While this trade will be child trade is the sleeping, other trades will continue execution to finish its task. Whenever it will wake up, then it will start from the task where it has left off. So in this program, two trades we are going to created. One is this trade child, and second is the main method. So look at here, in main method also we are going to display 1 to 5, and this trade is going to sleep for the 1000 milliseconds. So look at there, we have started from the main thread while m equal to 1. After that, trade is going to sleep for the 1000 milliseconds. Meanwhile, other trades, child trade has started execution. So child trade has main trade is sleeping till child trade is executing, trying to finish its job. So till that it has finished displayed up to the 1 to 3. Now main trade has backup. So main trade has backup. Main trade has slept for the m equal to 1. Now backup, it has to start again. It has to work from where it has left off. So it has left off to m equal to 1, then gone for the sleeping. Now again it has started, and it has started from the here only. So m equal to 2. Again it has gone for the sleeping, then child thread is executing. Similar types of the n number of threads can be created. Now, why I am saying that Java is the multi-threaded, because whenever we are going to start the Java programs, then by default 2 threads are created. One is called daemon threads, another is called non-daemon threads. These threads are called the non-daemon threads. Daemon threads run inside the background to support the non-daemon threads. Like when we are typing the windows, then 2 threads are automatically assigned. One thread is involving somebody is asking the questions. Okay, so these are the thread life cycle. There are the some books has given 5, some books has given 4 states. One is the new, second is the renewals. When we create the threads, that is the newly states. And when we start it, then it is ready to, it becomes the renewable states, but not yet started to run. Then renewable states becomes the not renewable also. Style like trade has gone for the sleeping, trade is the waiting. There are the various inbuilt methods occurs. Then finally, once the finish its job, then trades will be terminated. Sometimes it is the blocked also, means it has gone for the indefinite times also. So here is these trades. This state represents the creation of a new trade but does not start it, means we have just created. Runnable, a trade is being executed by the JVM when we call the run method. Not runnable means if any of these methods are listed here occurs, then it becomes the not runnable. But not terminated, again it becomes the runnable also. Then finally, once it finished the job, then that can be terminated, or any interrupted occurs also. In that case also it can be terminated. So look at here, these are the trades life cycle starts. We have created here like new trade, new T1 or trade 1 equal to new trade. Our new trade is created. Now when we calling the start method, then it becomes the runnable. Trade scheduler will assign it to finish the job. Once these methods are occurred, like wait method, yield method, sleep method, then it becomes the non-runnable. After non-runnable, when we call the join method, again it becomes the runnable. And either suppose we have created the trades and some interrupts occur, then directly it will be terminated. If after completion the job, that time also it will be terminated. After non-runnable, some interrupts occurs, then again it will be go to the terminate. So these are the life cycle of the threads. Now, these things I have already explain to you. Just I would like to show you the diamond trade example. Before that, trade priority, I have already explained to you. Like look at here, by default priority would be the normal priority or average priority, 5, but we can change it. Maximum priority is 10. We cannot set the priority more than 10. We can set the priority only this ranges 1 to 10, maybe the 6, 7, 8, 9, or 10. So these are the priority. This way we can set the priority also, get priority also. These are the predefined method. Then is live, is join, we can check it. Now, there are two types of trade, as I told you the beginning also, daemon trades and non-daemon trades. So the user defined trades which we create, we used to create, that is the by default non-daemon trades, but we can make it daemon trade also to observe whether daemon trade is existing or not existing and how it is working. So but by default Java create two threads. One is the daemon which runs beside the background to support the JVM for garbage collections, background monitoring also, and one is the non-thread, maybe the more than one non-thread also. So a daemon thread is a low priority background thread that provides services to user, means non-daemon thread. So its primary characteristic is that it does not prevent a program from existing. The runtime environments will automatically terminate. I will give one demo about the daemon threads and non-daemon threads. Then I will move from the here. Here is the program. 1 second. Just I am finding that daemon. Is it visible?
Yes, sir.
Okay, look at here. Here, this is the example of the daemon thread. Here we are using the runnable interface. So daemon demo, here look at there, set by, as I told you, by default user defined thread is the non-daemon threads. So we need to convert it into true value, pass the true value, because we are going to create the daemon threads. User can also create the daemon thread. So there is a predefined method set daemon. We have created thread th equal to new thread here. So set daemon true means now this th thread becomes the daemon thread. As I told you, whether the daemon thread or non-daemon threads, we can complete the task using the run method. So inside the run method, look at here. First, we wanted to check whether this is daemon thread or not. And here we are going to display the value I equal to 1 to 100. As I told you, daemon thread does not complete all the tasks. It only job of the daemon thread is to support the services, support the non-daemon thread to complete its task. Once the non-daemon thread is finished its work, then daemon threads will be automatically terminated, or JVM will terminate, close this, stop this thread. So here, this is the daemon thread. This thread is a daemon thread, and inside the main method, we are using the non-daemon thread. So what is the service or task of the here non-daemon threads? We are going to execute I equal to 1 to 6. We will see that while this non-daemon thread is executing, this daemon thread is also working. But once this non-daemon thread will finish its job, like it will display up to the 1 to 6, then this daemon threads, whether it has completed displayed 1 to 100 or not, in the mid, when it will finish, non-daemon threads will finish, daemon threads also has to be terminated. So these things I am going to show you. Here visible, not visible, okay. Stop sharing. Look at here. we have compiled this, then we have run this Java daemon thread. Look at here, it has started from the non-daemon thread. Meanwhile, in background, this daemon thread is also working, running. Like the first line we have set is daemon true because we have set the value true. Now look at there 1, 2, 3, 4, 5, 6. Means background this daemon thread is the running. And non-daemon thread was the main method inside the main method. So that is the also running. Like 1, 2, 3, 4. Then because we wanted to check the cross check whether daemon thread is existing or not. So meanwhile, we have reached up to the 4. In backgrounds, daemon thread is also running. 7, 8, 9. Now again after 4, this non-daemon thread 5, 6. Then again daemon thread is the running. And daemon thread is displayed 10, 11, 12, 13, 14, 15. If you remember the code, in using the daemon thread, we are trying to display from the value 1 to 100. Look at here, the daemon thread is not display up to the 100 value. After displaying the 15, it has been terminated by the JVM. Why? As I told you, it job of the daemon thread to only support the non-daemon thread to complete its task. Look at here. What was the job of the non-daemon thread? To display the value 1 to 6. So here 1, 2, 3, 4, 5, 6. When non-daemon thread has finished its task, daemon thread has terminated automatically by the JVM. It did not complete its task. So these things I wanted to show you actually concept of the daemon and non-daemon thread also. There are a lot of the another concepts also, thread synchronizations, thread communications, inter-thread communications, and all those things. So daemon and non-daemon is clear, na? Any doubt in daemon and non-daemon thread? No. Yes. So similarly, there are the very few applications, like as I told you, the daemon threads automatically created by the JVM and runs inside the background of the JVM, like garbage collection to free the memory space in garbage collection. This is a feature of the Java also. That is taken care by the daemon thread. Another application is the background monitoring, like in the case of the network connections, whether it checks all the networks are working properly or not, or some other resources also. Third one is the auto saving and logging. Very few applications that is done by the daemon threads. Then synchronization. In synchronization, when we make two threads communication, one thread with the another threads. So here is the like n number of the threads want to use the method. Any method, the system will not allow them to do so. The highest priority thread will lock the monitor for the method and making it inaccessible to the other threads. In case of the synchronizations, we take care all those things also. That should not be becomes the deadlock. It doesn't mean that all the threads are going to communicate. So there are the notify method and notify all method also. If one threads want to communicate with another threads, then we are using the notify method also. If one threads want to communicate the more than one thread, then we are going to notify all method also. There are the other examples also I have for the inter-thread communications. So same way we can go for the other use of the methods. Now, I would like to summarize the topic, how multi-threading plays a vital role in the real life also. Like when we open the documents of the doc files or WPS files, then we might have observed that if there are more than one threads are involving. Say 2, 3 threads One is the demonstrate that runs in background, and two non-demonstrates are created automatically. Like we are typing something, then one thread is involved to set the formatting and like font size and etc etc. Second thread is involved to take care of the input, whatever we are trying to type there. And third thread is running inside the background things. So these are the gist of the today's topic of the multi-threading. So I would like to stop now. Any questions, you please ask me.
Thank you so much, sir. Participants, if you have any doubt, you can clarify your doubts.
Okay, thank you. I think no questions because this is
Yes, sir.
the off time now, so everybody is in a hurry to leave the office. I was waiting for to this talk only. All of the staff members have already gone
Uh-huh.
because in room network is the very slow. That's what I use the office network. But I don't know why the network was also slow here in the office.
Okay, sir. Thank you very much, sir, for your enlightening presentation. Your expertise and practical insights into Java multi-threading have certainly enhanced our understanding and inspired us to explore more. Thank you very much, sir. To
Thank
express
you,
our
madam. Thanks
thank you.
for invitation, inviting me. In
Thank you so
future
much, sir.
also, I would like to give my research area also. This was the very short period of time I was requesting by one of my colleagues. They said, please give this talk. So
Sure, sir.
thank you all of the organizer and best wishes.
Thank you.
Shall I
To
leave now?
express, sir, please wait. To express our gratitude to all those who contributed to the success of today's webinar, I respectfully invite the eminent academician and esteemed Honorable Secretary of IEI, Salem Local Center, Dr. R. Satish Kumar, sir, FIE, to deliver the vote of thanks.
Thank
Sir, please.
you, Satya Madam. Thank you. Very good evening to all the participants. At the outset, I submit my heartfelt thanks to Dr. K. Tangaraju sir, who immediate post chairman of IEI Salem Local Center, who proposed the welcome address in a very warm and pleasant manner. Thank you very much, sir. I am very happy to thank today's resource person, Kamakya Narayan Singh sir, from Kalinga Institute of Industrial Technologies from Bhubaneswar, Odisha. Thank you very much, sir, for your wonderful and insightful presentation today. This is very much useful to the young minds to learn about the Java multi-threading. Thank you very much, sir.
Thank you, sir. Thank you for the invitations.
Yeah, thank you. Thank you so much, sir. Nice presentation, sir. Thank you.
Thank you.
I
Thank you.
thank all the engineering stock committee members of our IIA Salem Local Center of this 32nd anniversary. This is the 139th webinar series organized by our Salem Local Center. I thank Dr. K. Tangaraju sir once again being a member of the engineering talk committee. Dr. C. Davamani madam, immediate post honorary
I would like to
Dr.
congratulate all
Kumaravel.
of you for the 32nd anniversary of your
Yes,
STEAM
yes, sir. Yes, sir.
platform. Yeah,
Yeah,
please go ahead.
thank you, sir. Yes, sir. INR sir and Armugam sir, all the I thank all the senior members, corporate members, committee members of our IIA Salem Local Center, student members, staff members, and everyone who made this event a successful one. And I thank Professor Satya from our institution, Department of English. Thank you for your for hosting this event. Thank you all. Good evening. Thank you. Thank you.
Thank you, sir, and thank you all for your participation and support.
Satya ma'am, thank you ma'am. Sai sir, thank you
Thank
sir.
you, sir. Thank you so much, sir.
Yeah, thank you, sir.
Thank you sir.
Shall
Yeah,
I leave now, ma'am?
yes, sir.
Yes, sir. Please, sir.
Yes,
Yes, sir.
thank you so much, sir. Thank you.
Thank you, sir.